Should I start? Okay, thanks everybody for coming. Thank you to CELT for allowing me to give this talk. I'm giving this talk on this a program called Codex, an AI agent, I suppose you'd call it. And I've only really discovered it like 2 or 3 weeks ago. And so I'm very much a beginner using it. But already what I've used it for is, let me use the word which is little short of incredible. It was first pointed out to me by one of my former students, Earl Bellinger. And although I'm going to talk a bit about how I'm using it for my own research, I really want to emphasize the fact that it can be used for almost anything in any discipline. Really, the sky's the limit. That's how I feel currently about this piece of software. It's based off chatgpt. And I'm going to show a few technical things about my subject, but that's just to sort of emphasize how good this software is. I'm not using it to give this as an academic seminar on what I'm researching in. I just want to give the flavor. I'm going to flash some slides which give you the flavor of my research, and hopefully you'll see the power of this tool. Okay, so I work in pulsating stars in astrophysics. These are stars which oscillate, they expand and contract regularly. And you can observe these when you make observations of the light coming from these stars. That's called a light curve. Here are some plots of observed light curves at what are called different wavelengths and the different types of stars. The one on the left here is a Cepheid. The one here is an Aurora Lyrae. These are infrared observations of Aurora Lyrae. These are the things I study. These are observations made by telescopes and so on around the world. And what I do is I try to model these stars theoretically on the computer. These stars pulsate because of the particular place they are in their evolutionary history. So this is what's called an HR or Hertzsprung-Russell diagram. And so stars are in a particular place in this diagram. And as they go through their life, they move into different regions of this diagram. That's called a stellar evolutionary track. And when they're in this green region called the instability strip, they start to pulsate. And that's the sort of stars that I've studied for 40 plus years now. The equations which describe this, I really want to just flash these up because I just want to show that it's a very complicated technical subject, but still within one evening, an undergraduate student can be playing around with models of pulsating stars. So these are basically the Navier-Stokes equations of fluid dynamics. The only complication is that there's radiation also in the mix. I just want to flash those. Those are partial differential equations. This is a Lagrangian description. They're fairly complicated. There's also a mass continuity equation. You'll have an initial static model, boundary conditions. There are other external inputs into this, something called an equation of state, opacities, which is a product of fairly advanced atomic physics. So there's a lot of things that go into these partial differential equations, and there's a lot of things that go into solving these differential equations on a computer. This is a sort of cartoon image of the sun, but you can think of it as any star. And you can think of different layers in the star. That's exactly how we solve these equations. We divide the star up into zones from the surface to the center and write these partial differential equations as algebraic difference equations, and then we can solve those pretty well. And an example of a code which does this is given by this website here, this link here. I'll just show you this on my, where is it? This is MESA star. This is the most advanced 1D radiation hydrodynamics code in the world currently. It's an open source code. That means anybody can get it. Anybody can install it. Anybody can help to develop it. I'm one of the people who helped to write the original versions of the stellar pulsation part of this code. But anybody can work on it. It's absolutely free. It basically works on, you need a Linux box essentially to run it, or a virtual Linux machine. So that's the sort of basic scientific tool in my field. And what Codex I've found can do, you can just literally tell it, I want you to install MESA, the Stellar Evolutionary Code, on my laptop. Just that, in those words. And it will go ahead and do it. And it will probably take about an hour or so to do, maybe less than that. It'll look at all the interdependencies, install those packages first. If you've had any experience of open source software, that's what I've been used to all my sort of computational life. It can be sometimes very messy. You have to have lots of packages installed first before you can install the package that you really want to work. This program Codex does all of that for you. If I were to ask a student, as I've done in the past, the first thing that students do if they want to work with me is to install this program on their laptop. It usually takes them 4 or 5 weeks to do that, and then another 4 or 5 weeks to learn a bit about how to use that code. It's quite a complex code. But this summer, I had a student, I have a student working with me over the summer, and he was able to install, using Codex, MESA-RSP with very little knowledge in one evening, and the next day he came to me and said, these are evolutionary tracks. So these are evolutionary tracks computed by MESA for 2 solar mass, 3 solar mass, 4 solar mass, 5 solar mass, 6 solar mass, 7 solar mass model. If I had asked a student before Codex, this program which I'm going to talk about, to do that, it would have easily taken them 1 semester to do. So my student Alex has already got up to that stage within an evening. And all he did was type into a chat box, install MESA, and then run 2, 3, 4, 5, 6, 7 solar mass tracks, put the tracks on a plot, and show me the PDF of the plot. So it even made the plot that you're looking at just now. It decided to put the colors in separately. It chose those colors. It put the scaling in, the labels, and you can see it also put the title non-RSP MESA HR tracks. I'll talk about RSP in a minute. But that was 1 week's work. 1 evening's work. Something which would have taken somebody else who didn't have this Codex program probably a whole semester to do. MESA-RSP is a sort of variation of MESA, which computes stellar pulsation. So MESA computes the evolutionary life history of a star, but MESA-RSP computes the pulsation of these stars. So that's what I study. It's a slightly more complicated code than MESA. And that's yet another sort of extension of MESA. So that would take another 3 or 4 weeks of work for a student without this program to install and run the test suite. So again, I asked my student Alex to do that, and he did that again over an evening. And I told him on I think last Tuesday. And I was really surprised to get an email. It was like in the morning. I told him around 9 a.m. to try this. And that evening, he sent me this plot. It was incredible. So this is the light curve of a pulsating star computed by MESA-RSP. So Alex had just installed this program using Codex, and he just typed in a chat box, compute a full amplitude model of a certain type of set star, and show me the V-band magnitude like it, and this is it. And it made a plot. It saved the plot in a PDF. It put in the title. It put in all the relevant things, axis labels, nice scale for the axes, a pulsation phase. It told you what the period was, 8.7667 days. told you what the peak-to-peak amplitude is, and this was done in one evening. Ordinarily, it would have taken an undergraduate student, even an undergraduate student, maybe a whole semester to do. And all this is typing English sentences into a chat box. Over last semester, the last 2 semesters, one of my students, Elizabeth Benke, who's now graduating, going on to grad school at Stony Brook, I think, worked on a project with me on R. O'Leary's, and she produced. So that her project was to look at R. O'Leary's, which is another type of pulsating star in globular clusters, get the data for these observations, sort those into a nice way, write a program to do a Fourier decomposition of the light curve, fit the light curve with this Fourier decomposition, get the color at various different phases of the pulsation, and look at how that period color relation varies at minimum light, mean light, maximum light. So just in me saying that, you can perhaps sense that it was quite a complex operation. And yes, it took her about 1.5 semesters to get to produce a plot similar to what I'm showing you on the screen here. So that was 1.5 semesters work of Elizabeth's work. She's a very bright student. She's certainly no slouch in programming or computational literacy or anything like this. And it took her 1.5 semesters. Alex did this, and I said this, she produced a plot very similar to this. The reason I say very similar is because this plot is produced by Codex, by Alex, who just typed into the chat box, gave the program the data that Elizabeth had, and asked the program to produce period color relations at minimum, mean, and maximum light using Fourier decomposition, all of those things that I said. And he just typed that in, and this is the plot that it produced. And it's a very, very similar plot to the plot that Elizabeth produced after 1.5 semesters or so of work. And by the way, this is something we're going to probably hoping to publish in the next 2 or 3 months. And that's the point I want to make. I'll come back to that at the end, that it removed the barrier to getting to the research problem, the technical barriers, which might be you need to know a bit of programming, you need to know how to make a plot, you need to get the data in the right format, you need to do a Fourier fit. All of these things ordinarily would take you quite a while to overcome, to get the skills to learn it. But now that is just gone with this program Codex. And this is probably the thing that this is a plot that was sent to me by my former student, Earl Bellinger, who's now a professor at Yale. This is an idea I had in the 1980s, early 1990s, and now it's going to come to fruition. And this was all done over, this took a bit longer, about a week of working with Codex. And the reason what this is a theoretical model of a pulsating star. The top left plot here, this guy is the light curve, but it's the light curve at different places inside the star. And eventually you'll get to the light curve at the surface. That's the light curve that we see in our telescopes. The thing on the right is the velocity curve. That's how fast the surface is moving in and out. And again, but it looks at different layers in the star until you get to the surface. And the bottom plot, that moving dot, tells you where you are in the star. So to the bottom left, where it says 400,000 on the x-axis, that's nearer the center of the star. The bottom right is near the surface. And the moving dot shows you where you are in the star. And the light curve and the velocity curve show you the light curve and the velocity curve as they are at that place in the star during the star's pulsation. So I can assure you that this is a very innovative sort of idea, and this is going to lead to a lot of very interesting results. But I've had students try to do this in the past, and they got close. I did it, in the early 90s, but it was all done manually, and it took me like weeks and months of effort. And I was a postdoc then. But I think Earl did this in like a week with the use of this program Codex. And remember what it did, it downloaded the program from the internet. It learned about the program. It installed all the prerequisites. It learned about the program. It was able to compute a full amplitude model, but then it was able to go into the program and get the output that was requested of it in the chat box, and extract those results and make a plot exactly as was requested in the chat box. This is just really incredible. There's no other words for me to use other than that. I just want to try to convey to you the complexity and the level of understanding that you need to make this slide. If you were to do it manually, you'd have to know something about pulsation, evolution. You'd have to know definitely very technical details about how the code was written, how to access that code, where the results of the code, how it writes them out, what format it writes them out, how to make plots of that. All of this, that will take you a postdoc, 1 or 2 months to get familiar with. Anyway, and we have this in about 2 or 3 weeks. So we're obviously going to be working on this. I'm going to be visiting Earl next week. So this will be a great topic for our research there. And so I wanted to emphasize that it does other things. So I told it, Codex, to write a one-page play called Identity. That's what I did. Write a one-page play with the title Identity. And give me the transcript of the play in a PDF. Here's what it gave me. I'm displaying that now. It's just a one-page play. I suppose I haven't really looked at it, but at least it did it. It told you what the characters are, what the setting is. It wrote it out in a format that, actors would know. There's a voice as well. It's not just 2 actors, Mara and June, and so on. It's in one page. Okay, then I think, and then I asked it to write a 12-bar blues. The one on the left-hand side I asked it to write a 12-bar blues in C. And if you know 12-bar blues, you know that the 5th bar is going to be the 4th of that scale. So the C major scale, the 4th is F. And it definitely, you can see the 5th and the 6th bars go to F. Admittedly, it's a very simple rhythm. But it actually said that when it produced the results. Admittedly, the rhythm is fairly simple. And that's a 12-bar blues on the left. On the right is interesting. It's a Bengali folk song, a very famous Bengali folk song written by Rabindranath Tagore. So I just asked it I gave it the title, or the title was written in English letters, transliterated to what the Bengali would say. And I asked it to transcribe the melody and write it up in Western music notation. And this is exactly what it did. And there you can see, this is a very famous Bengali folk song. And it's actually a very beautiful Bengali folk song, and it was able to do it. If you tell it to do some pop song or something, some Dire Straits song, which I tried, it'll come back and say, I'm sorry, it's copyrighted. So this one is not copyrighted, so it doesn't have, so it could do that. I did play it a bit, and it is pretty similar. The rhythm perhaps could, these are all quarter notes. You could perhaps change those things a bit, but that's really amazing that it could do that. Okay, so this is all done by this program Codex. And the key point that I want to make, which I hope will be of interest to people, to faculty and staff and around the campus, is that in most research projects, there are a lot of technical things technical skills that the student has to acquire or overcome in order to make progress on a research problem. The student can perhaps understand the research question, but in order to be able to get to that point, to be able to make meaningful contribution to that research question, he or she will probably have to acquire some technical skills, and that sometimes can take some time. That could be programming, object-oriented programming, sorting through a database, or anything like this. And sometimes those things can take a bit of time. What Codex will allow you to do is to circumvent that. Students can get much, much more quickly to the research nub of the problem. And I believe, obviously there are some disadvantages to that, but I think the advantages outweigh the disadvantages. They can definitely learn the technical skills needed later, but it won't, this Codex program will allow them to get to the research problem, and hence I think maintain their interest and enthusiasm in the problem much more quickly. So you've probably heard of Stephen Hawking, the famous physicist. So he said that for many years, he understood the mathematics behind general relativity, but he didn't really develop a physical intuition for the physics behind it. It was only after about 10 years that he started to really get an intuition for the physics behind it. He could only do that because he'd already had the technical mathematical skills to work in that subject. So I think this Codex program can be casting that light. It will help our students to acquire the technical skills they need to attack a research problem, and then slowly over time, they can acquire the intuition they need to really and bring that to bear on the research problem. And another example is a simple one in linear regression, which is just fitting a line to some data. If you were to talk about this to students, you normally need to explain the idea of least squares regression and so on. And students would probably need to acquire some coding to apply this to a large data set. Again, Codex takes this step out, this second step, but at least for the moment. And I'm going to try to show you this part just now. Let me see what I have. Oh, I'm going to try to show you this part in an example now. So let me get to Codex here. So this is what you would see if you install Codex. So Codex is this program. It runs off ChatGPT. If you were to Google Codex and go to their website, this is what you would see, and it's very, very easy to install. So just if you've got an Intel Mac, which most of you had, you'd click this black button and it'll download the application file, and then you just install it as you would any other package on the Mac. Don't click on download for Intel Mac. For some reason, clicking on download for Apple Silicon, even though I have an Intel Mac, that's the one that worked. So when you click it and download it, you have to probably create an account, because I think it interfaces with ChatGPT. This is something that you'll see. I've been working on it a bit and testing out various things. So I'm going to do a little linear regression here. I did this before. I've set up this file before. I wonder if it might even remember that. It might say can't find it. Okay. So it's thinking. And it was just the file that I had is just a very simple thing. I'll show you the file here. It's trying to find it, I guess. Where is it? Maybe it's not finding it. Okay, that's where is it? Okay, it's actually found it. There you go. It worked for 20 seconds. And it was just the file was x equals y. So it was just a column 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So y equals x. And it saved the plot here. It's in this form. That's the plot that it made of that file. Actually, so the file was here, test1.dat. So just in case you think that it's just doing that by luck, I'm going to ask it to. Oops. For the first column, this is a different file, which is 1, 2, 3, 2, 4, and so on. It's y equals 2x. And you can see that it will do that just, and it literally tells you what it's doing. It found, tested up to that. I'm running the regression and saving an updated plot. And there you go. It's just, so if you were to try to explain linear regression to a student, I submit that something like this, if you were displaying it, would be very intuitive. And you could almost immediately after this get to looking at analysis of a complex data set, which I'm going to do. And then later on, the student can come back and say, well, what is that? How do you compute the slope? How do you compute the intercept? What does it really mean to have to say it's a best fit line? What does that really mean? I submit that a student looking at it like this will be much more enthused and energized to try to understand linear regression at a much deeper level. So I've already got a program. Let me show you this. So in a much more extensive way, beforehand I downloaded data for the LMC. The LMC stands for the Large Magellanic Cloud. And let's see what it does if I ask it to do the same thing again. So I'm going to download the LMC Ogle Cepheid fundamental mode data and make a plot with log of the period on the x-axis and the I-band magnitude on the y-axis. So it'll take a bit of time to do this, but it can do this. I'm pretty sure it can do this. I did it before, and I saved the data, and it's actually going to tell you the things that it's doing. So you can see that I just essentially wrote in the text box in English what I wanted it to do. And it's telling you what it's doing. I'll refresh the Ogle LMC fundamental mode Cepheid catalog, extract the mean I-band magnitude, then plot log 10 period against I. I'll use the astronomer magnitude. Yes, so I'm not. The catalog is downloaded. I'm not sure what it meant by the sandbox network can't resolve the Ogle host. So I'm trying the same download with network permission. So it's actually creating a Python program which does the plotting. It's downloaded the data, and it's actually writing a small Python script to make the plot. And I didn't tell it, this is quite an extensive data set. There's 2,000 or so stars. I didn't tell it which columns it should plot. It's figuring that out itself. I just told it to plot the I-band magnitude against the log of the period. So it's going to find which of those columns in the data set at this external database represents those two quantities that I asked it to plot. And it's going to finish pretty soon, I think, because I did this before. Okay. So the script is ready. I'm running it now. Then I'll validate the SVG and show the plot. So it's really incredible. It tells you that it's doing some checks as well. Okay, there is the plot. That is the plot. It tells you the slope. There's the plot. This is unbelievable. That is the LMC mean I-band PL relation for fundamental mode Cepheids. There are 2,439 data points. It tells you the equation describing the best fit line. I equals minus 2.917 log P plus 16.844. I bet you if I asked it to give me errors on the slope and the intercept, it would do that. Each of those blue dots is a different star. And just to show you where this data set is, it really went to this website and it looked at classical Cepheids in the LMC and it got the data from there. So it's something quite remarkable. And let me just say again, to make this, oops, sorry, can you hear me? Can you still hear me? Listen, I just knocked the, can you hear me? Yeah, can you hear me?
Yeah, you're good. You're good.
Okay. I had the capstone physics students last semester, in the fall semester, and we had an excellent student. Some of you in the audience will know her, Kamayani Vishari. She made this plot. But at that time, I didn't know about Codex, but it took her the whole semester to do it. That's not in any way criticism. She's a very smart student. But in order to download the data, there's 2,439 stars. You can't obviously do that one by one. She had to develop a script to download it automatically. Then she had to fit a Fourier decomposition to each of the light curves, extract the mean magnitude, and so on and so on and so on. That took her almost like a semester to do because she had to acquire the skills, the programming skills, and so on to do it. I've just done it in 5 minutes here. So a student now who wants to work with me can be at this stage in practice in just 10, 15 minutes. And I contend that if a student who's interested in astronomy or astrophysics, and it doesn't have to be in that field, that's just an example. When they see themselves, let's say in quotes, having made a plot like this, it's going to make them it's going to give them a lot more enthusiasm and energy to go to continue with the project. And okay, you might say, well, they don't know any of the technical details behind all of this, and I accept that. But those sort of things you can acquire at a later stage, as I said in my example related to Stephen Hawking. And I believe that this is the main thing about this program, Codex, in the physical sciences, in the STEM fields, and I think it has tremendous applications in all disciplines. I showed you the plot of the one-act play and the pieces of music that it was able to transcribe. Let me go back. So this is what you see, and you see that I literally just talked to it. If I were to just tell the student in words, this is the aim of your research project, that's exactly what I typed into the chat box, and it was able to do it. And this is really the main point of why I wanted to give this talk. I wanted to encourage people. I don't know if such a thing has been mentioned, but this is going to tremendously increase the accessibility of our students. By accessibility, I mean the ability of students to get more quickly to the research problem that they are looking at, or it could be used in a teaching environment, and sort of circumvent or circumvent the technical skills that they might need initially to get to that point, which they can acquire at a later stage. And so that's why I feel is an important point, which I think this particular program, Codex, can make a tremendous sort of contribution in the life of Sun Oswego, both in the research setting and I think also in the pedagogical, in a classroom setting. That's pretty much what I wanted to say. Do you have any questions?
Hi, Shashi. It's Anne calling
Hi.
from home. Yeah, I find it frightening on how much it could do.
Yep.
Amazing for those of us who know the background
Yep.
and how things are actually done and how much time and effort it takes.
Right.
Yes, I know the students are eventually going to find their way to it anyway.
No. Yeah.
But I'm worried about not giving them the foundation. So
Yeah. Well,
I'll still teach them the foundation in modern physics lab, and then they could do whatever with you afterwards.
No, I take your point, Aaron, and as I said, there are some advantages to this and disadvantages. And the disadvantages will be, as you said, you know, you and I and other people who got to this level before all of this came, and we had to struggle long and hard to understand these computer programs and the physics. That's true, but I think that's why I said if we use it in a good way, it can help to ease the pain of learning those technical skills by allowing you to look at the prize, you know, like that plot that I showed you a bit earlier than perhaps you would have.
Yeah.
I think that eventually that I think is sufficient to outweigh the disadvantages.
Well, I have to admit, while we've been sitting here, I used a search to try and find a missing subroutine of a Fortran code from 1977, critical to my research, that I have not been able to find. So maybe it will find it out there.
Yeah, sure. I think Preeti, you had a question?
Yeah, hi Shashi. So a little bit along the lines of what Anne was saying, but if you go back to that plot, the linear regression,
Yeah.
where it said that the model was basically y equals x.
There were two. I did one. It was y equals x. It's not basically y equals x. It was y equals x. This one that you see on the right, it was
Yeah, but then what happened to the y-intercept here? Or is that, am I reading the
if you
units?
extend
The units are
yeah, if you look at that's not zero there.
right. Okay. Okay.
You could
So
probably tell it to have a different, you know, axis scale. This was just, you know, a very quick.
right.
Scientific
I understand that. But then, you know, when a student is looking at it, this
Yeah,
kind of a graph, they have to understand
yeah,
that, or they have to at least be aware of the fact that, you know, it's starting out at not
yeah,
zero. And
yeah.
so
But that
the
I agree, and but I think
so when you say the
your job in
technical
explaining
details,
that, your job in explaining that will be made easier if the student has done something like this on his or her laptop. And
right. So
I
I'm
think,
playing a bit of a devil's advocate here. So when you say technical details, you've taken away a lot of the computer science and coding, of course, but you've also taken away a lot of the math,
yeah, no,
right?
I, yep, go ahead.
So for example, you know, it's doing some linear regression, which is great.
Yeah.
But what if linear regression in a different situation is not the best fit? Will the student be able to realize that?
Those things I think you can build in incrementally into a
Mhm.
lesson or a series of lessons. And so if you are just starting off by teaching students about linear regression, you probably start off with a y equals x thing like this, and then you maybe go on to something like this or later on. And just, So just imagine this. I just want this plot. In order to get to this stage, Kamayani, you know,
Oh, I definitely agree that, this is, way, way more than what one could even imagine.
yeah.
The
So
amount of time and coding, I mean, it drove me crazy enough, so I gave up on the master's in computer science
yeah.
while I was doing my PhD. So absolutely, my concern is just that, if students don't need it, they won't learn it,
Uh,
as we all know.
I agree.
It's not just
But
students,
that,
everybody.
I agree, but then that was perhaps the job of the instructor or the professor to bring it into the class in a way that
Hmm.
they will need to learn the fundamentals behind it. So if you were asking a student, for example, as I said, it took Kamayani a semester to get to the
Mhm.
stage of producing this plot, and she did it herself.
Right.
She learned all the skills you need to get to that point, and that was really, and obviously, and you know her, she's a very intelligent student, and so, but just imagine getting to this point I got to this point in 10 minutes. So she would have got to this point in 10 minutes after the first class.
Yes, yes, and I
To,
totally, appreciate the enormity of that. I'm just a little bit afraid, as Anne was saying, that students are going to be like, in learning some of those technical details, they also learn a little bit more about what they're doing and what it means.
and
And
that's
yes, that's like, okay, everybody's job to go back and
correct.
figure out what it was doing. Do you know what it does on the back end? Is it just
So it's
because most of the AI stuff uses like large language models?
yeah. So this is a large. It uses ChatGPT. So that's what it interfaces completely with ChatGPT.
So
But
what does that mean? On the back end, what is the Chat GPT doing?
so
Preeti,
the
I'm
large
seeing,
language
uh,
models, all the basic way a large language model works is that by assigning, if you're given a basic input string, it assigns a probability to the next string that will come in that sequence. And it does
Right,
that.
but it does that by examining the patterns. And sorry,
No,
Anne was saying something?
it
yeah,
does that
yeah,
by essentially looking at all of the websites and everything that it can find in the world and
Right.
forming a model of given a certain a set of input parameters, what's the most likely parameter or what's the most likely string that's going to come next. That's large language models in a nutshell. There are other things to that. So actually
Yeah.
you can
So
think of it as a regression in a linear regression like you see here. There are two parameters. There's the intercept and the slope, and you're explaining, let's say, 2,439 variables with two parameters. All right, but now if you think of the entire world, there's billions and billions of variables, and there may be millions and millions of parameters. So ChatGPT is essentially having a bunch, millions and millions of these parameters, like the slope and intercept, so maybe it's got a parameter for whenever somebody asks me about a Bengali folk music, I'm going to go to this particular part of the regression and find the output for the input that I'm given. That's how these large language models work. I
yeah,
still
so I
find,
know how large language models work, and what, you were saying something about like if I put in something in dire straits, it's going to come back and say copyright
yeah,
violation. But then the point is that, it's somebody's else's work that you're building on. And if that work is that's the whole thing of looking for the patterns, right? Somebody else's research, etc., that you're looking at, and it's drawing from all of that very fast, of course. So that speed is amazing. And then, but if there is something so if the Bengali song was copyrighted,
yeah.
you wouldn't be able to do this,
No,
right? And then
yeah,
you're using the fact that, okay, nobody actually got credit for it, so now I can use it. You see what I'm saying? I mean, It's a matter of,
All of so in this case, this particular data that you got, this is in the public domain. It's been published, so anybody can
absolutely,
use
I
it.
agree. I agree. Absolutely.
Anybody's. So that's a separate question about that. Those questions will definitely come up about ethical issues and legal issues and
Right,
so
right.
on. But so that's not what I wanted to talk about today. I wanted to
I
talk
know,
about
and I'm not, I totally agree
yes.
that this is absolutely phenomenal.
Yeah,
Uh,
I just wanted
I'm
to
just saying that there are
emphasize.
also other issues.
No, yeah, and that's for another topic and
Yes,
yeah,
absolutely. I
another topic. And
agree.
in fact, when Earl showed me this codex, I said to him, "So who's going to be the author on this paper? Me and you and Codex, or Codex and me and you, or what?"
Exactly. Right.
So that's another, topic for discussion. So, because you could say, well, the people who wrote the code for Codex and ChatGPT, OpenAI, I guess, what should they be given some credit? Because they essentially developed this large language model which allows all of this to be done. Maybe, I don't know the answer to that question. But so for example, a student submits this plot that you see right now as a homework, as their answer to a homework assignment, maybe you could ask, has the student done it themselves? Right? I don't know, but this is I certainly,
Sorry, we should also ask Anne to complete what she was
yeah,
saying.
sorry.
Yeah, sure. So I fell into an interesting trap this spring. I asked my modern physics students to give presentations on equipment and experiments that we don't have.
Right.
So I asked AI to help me generate some faux data sets to help save me some time coding it up myself.
Okay,
Hmm.
It basically jumped into Python most of the time.
right.
And so I guess going forward, since I think some of the software and routines that I teach for least squares analysis and curve fitting will eventually not be compatible with the world and might not be accessible with all their GUI windows.
Yeah,
I thought about, will I eventually allow students to use AI to write a Python code for least squares analysis?
Hmm.
And that's the fence that I'm on. Will they document and understand the mathematics inside of it, or will they use it blindly? I haven't decided on that. But I
Yeah,
have, yep,
and I agree. And I mean, these are, new questions for us, not just, pedagogically speaking, but even, as just really substantive questions about our courses and what we teach
yeah. I
and what
think I
to
can't
change.
I can't possibly ever teach computational physics again because,
Yeah. And some of our statistics courses become redundant.
well,
yes.
for
Mhm.
me, I already have evidence that students, now that I know what code written by Gemini looks like, I already see footprints in things that have been submitted. So I haven't done complete forensic analysis, but I think unless I put them on the 13-year-old computers in room 276 without internet connection, uh, and had them do it in front of me, I don't know that I would get their own work.
Mm. But Shashi, none of that is to take away from what you have done in your presentation today.
Oh
So
no,
I just wanted to bring people's attention to Codex. That's all.
absolutely.
I think
And
it will
I'm
be,
a sort of a new entrant
I
to
think it'll be
using.
very
Yeah,
important. There may be other programs that do something similar, but this is just the one that was brought to my attention. And as I tried to show, it's not just for the sciences. It could be used in the humanities, social sciences, in music, theater. So it's with us. And Earl sent me an email the other day and said, the future is today. I'm sorry, but we're in this world now. So we have to somehow make the best of it and go forward.
absolutely.
So,
Absolutely. Thank you.
yeah, I also think this talk was very nice, Shashi. Do you know if there's a Codex equivalent that's not ChatGPT? I swore off ChatGPT.
I don't know off the top of my head. There probably is. Is there?
Something in
Why don't you
cloud,
like
probably.
ChatGPT?
Sorry, what, Shashi?
Why don't you like ChatGPT? What?
Well, I have general problems with AI and the environmental and economic damage that it's doing.
Oh, okay. All right. I understand.
But for other, I guess I'll say political foundations,
Okay. There may be other things related to that. I think I've got to stop because there's another talk after this. Anyway, thanks a lot, guys.
Hey,
Thank you.
very interesting work. Thanks.
Bye.
Bye.